Okay, so now we're going to talk about representation of if-then statements as statements with or in them. So as you can see right here, if P then Q, or P implies Q, is logically equivalent to not P or Q. All right, so number one says, rewrite the statement in if-then form. This loop will repeat exactly n times if it does not contain a stop or a go-to. So this sentence is a little different than the normal if-then sentences. Usually when you see these sentences that has like this part right here, and then if, and then another statement, that means whatever is after the if is the first part of the if-then statement, and then whatever is at the beginning is the then part of the if-then statement. So if we wanted to rewrite number one, we would say if, and this part right here, if the loop does not contain a stop or a go to, then this loop will repeat exactly n times. There we go. All right, let's do number three. Number three says freeze or I'll shoot. Remember that P implies Q is logically equivalent to not P or Q. So in this case, they give us the right-hand side of the logical equivalence. So not P is equal to freeze. Q is equal to I'll shoot. We have the Q, which is what we need here, but then P, we would have to take the opposite of not P. So the opposite of freeze is don't freeze. So if we were to rewrite this sentence as an if-then sentence, then we could say if you don't freeze, then I'll shoot. There we go. That's how you would write freeze or I'll shoot in if-then form. Number 16 and 17 we're going to do. It says in 16 and 17, write each of the two statements in symbolic form and determine whether they are logically equivalent. Include a truth table and a few words of explanation. So 16 says, if you paid full price, you didn't buy it at Crown Books. And then the second sentence says, you didn't buy it at Crown Books, or you paid full price. So let's break that down, break these two sentences down into smaller pieces and put symbols with them, and we can create a truth table, all that fun stuff. So let's start with the if-then statement. So P would be you paid full price. Q would be you didn't buy it at Crown Books. And they didn't have the word then, but it's implied. So you didn't buy it at Crown Books. All right, and that will look like P implies Q. And then second sentence, you didn't buy it at Crown Books, so that's Q, or you paid full price, or P. Let's see if these two statement forms are logically equivalent. So we have two variables, P and Q, so let's put that down. And then we have our two parts, we have P and Q and P. So now we can just write P implies Q, and then Q or P. There's two variables, so we can just write true, true, false, false, and then true, false, true, false. True implies true is true. True implies false is false. False implies true is true. False implies false is true. Q or P. True or true is true. False or true is true. True or false is true. False or false is false. These two columns are not the same, so we can say statement forms are not the same because truth values are not the same in these columns. They're not the same. Okay, let's do number 17 now. Okay, number 17 says, if 2 is a factor of n and 3 is a factor of n, then 6 is a factor of n. The second sentence says, 2 is not a factor of n, or 3 is not a factor of n, or 6 is a factor of n. So let's break down the first sentence. So it says, if something, then something. So we can say P is 2 is a factor of n. So this right here is P. Q is 3 is a factor of n. This right here is Q. And then the next part, then 6 is a factor of n. 6 is a factor of n could be R. 6 is a factor of n. So we can say P and Q, put that in parentheses, implies R. Because if 2 is a factor of n and 3 is a factor of n, then R is a factor of n, which is what the first sentence is. And then the second sentence begins with 2 is not a factor of n, so the opposite of P. So the negation of P, or 3 is not a factor of n, or the negation of Q, or 6 is a factor of n, so or R. Now, the commutative law says that we could put parentheses here or here, and it's this exact same thing. Those, regardless of whether you put the parentheses here or here, those two statements are logically equivalent. So I'm just going to put parentheses right here, because when we're building a truth table to compare these two statement forms together, it's going to be a little difficult to take all this in at once. We want to compare just 2 parts, not 3 parts altogether. So let's make a truth table now to compare this statement form and this statement form. So there's 3 variables this time, so let's see. I'm going to start with P, Q, and R as our first columns. And then after that, the next most basic component is the negation of P, and then the negation of Q. And then the next most basic component is P and Q, and then the negation of P or the negation of Q. And now we have this part, we have this part, we have this part, we have this part. So now we are ready to look at the truth value of the entire statement forms. So P and Q implies R, and then the negation of P or the negation of Q or R. Okay, so since there are 3 variables, we can do the handy trick of just writing true, 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 true 4 times, and then false, 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 false 4 times, and then true, true, false, false, true, true, false, false, and then true, false, true, false, true, false, true, false. And then the negation of P would be false, 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 false 4 times, and then true, 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 true 4 times, and then false, false, true, true, false, false, true, true. And then P and Q is true and true is true, true and true is true, true and false is false, true and false is false, false and true is false, false and true is false, false and false is false, false and false is false. And then P or the negation of P or the negation of Q. So false or false is false, false or false is false, false or true is true, false or true is true, true or false is true, true or false is true, true or true is true, true or true is true. Okay, now P and Q implies R. So true implies true is true, true implies false is false, false implies true is true, false implies false is true, false implies true is true, false implies false is true, false implies true is true, false implies true is, false implies false is true. Okay, and then the negation of P or the negation of Q or R. So false or true is true, false or false is false, true or true is true, true or false is true, true or true is true, true or false is true, true or true is true, true or false is true. Okay, so as you can see here, these 2 columns have the same truth values. So the statement forms P and Q implies R, and negation of P or negation of Q or R are logically equivalent.